Hello friends, welcome to my channel. Today we're going to dive into a question that we all see every day but maybe don't question much: why is the sky blue? Imagine, you wake up in the morning, you look out the window and you are greeted by that deep blue sky. But why blue? Why not red, green, or any other color? Sometimes it is even orange at sunset. How is that possible? The color of the sky is a scientific miracle. Science tells us this: it all starts with sunlight and the atmosphere. But the story doesn't end there. Why isn't the sky purple? Why is it orange on Mars? Or what would happen if there was no atmosphere? In this video, we will unravel the blue secret of the sky in a scientific, experimental, and a bit of fun way. Surprising facts, a simple home experiment, and the sky colors of different planets will all be here. If you're ready, let's embark on this colorful journey. Let's take a step-by-step look at why the sky is blue. It's all based on science, but we'll also discover how these colors change with different situations and planets. Are you ready? 1. The dance of light, colors and wavelengths. It all starts with sunlight. Sunlight looks white, but, actually, contains all the colors like a rainbow: red, orange, yellow, green, blue, indigo and purple. Each of these colors has a different wavelength. For example, red light has a long wavelength, about 620 to 740 nanometers. Blue is shorter, around 450 to 495 nanometers. So why is this important? Because the wavelength determines how light is scattered. Rayleigh scattering, the triumph of blue light. The real reason why the sky is blue is a phenomenon called Rayleigh scattering. In the 19th century, a scientist named Lord Rayleigh discovered it. When sunlight enters the atmosphere, air molecules, mostly nitrogen and oxygen, scatter it. But not all colors are distributed equally. According to Rayleigh's rule, shorter wavelengths of light scatter more. So blue is much more diffused than red. So when you look up at the sky, that scattered blue light reaches your eyes and the sky looks blue. But wait a second, purple light has a shorter wavelength, so why isn't the sky purple? Why not purple? Our eyes and the sun. Good question. The wavelength of violet light is really shorter, about 380 to 450 nanometers. In theory, it should scatter more. But there are two big obstacles. First, there is less purple light in sunlight than blue. Second, our eyes are more sensitive to blue. The cone cells in our eyes perceive blue light better than violet light. So, even if the purple light is scattered, we see blue, not it. Experiment time. Let's imitate the sky with milk and water. Now let's test it at home. Put a few drops of milk in a glass of water. Take a flashlight and shine the light into the water. What do you see when you look at it from the sides? A blue color. That's because the milk particles scatter the light, just like the atmosphere. If you shine the flashlight directly behind the glass, this time you can see an orange color, mimicking the sunset. This simple experiment is a great way to understand why the sky is blue. Sunrise and sunset, the order of red and orange. So why does the sky turn red or orange at sunrise and sunset? The answer lies in the distance the light travels. When the sun is low on the horizon, light travels through more atmosphere. On this long journey, blue light is scattered and lost, leaving long wavelength colors like red and orange. This is more pronounced in dusty or polluted air, because the extra particles emphasize red. Different situations: high altitude and pollution. The color of the sky does not only depend on the time. When you climb high mountains, the sky looks darker blue. Why is that? Because the atmosphere is thinner and the scattered light is reduced. On the other hand, if there is air pollution in cities, the sky can be gray or cloudy. Dust and particles scatter light differently and spoil that clear blue. Mars and other planets, changing sky colors. Now let's go to space. Why is the sky on Mars orange-red? Because Mars' atmosphere is thin and full of dust. These dust particles scatter red and orange light more. Blue scattering, like on Earth, is not dominant here. What about gas giants like Jupiter or Saturn? Their skies can be greenish or brownish because of gases like methane and hydrogen. The composition of the atmosphere paints the sky a different color on each planet. If there was no atmosphere, black sky. Think about this: if the Earth had no atmosphere, what would the sky look like? The answer is simple: black. There is no atmosphere in space, so light is not scattered. You can see this clearly in photos taken from space, just the sun and the stars, with a black void in the background. The atmosphere is like a magic curtain that gives the sky that beautiful blue. Historical discovery: Rayleigh's legacy. Who solved this blue mystery? In the late 19th century, Lord Rayleigh mathematically explained how light is scattered in the atmosphere. His work became one of the cornerstones of the science of optics. Before him, people saw the color of the sky as a divine sign or just a mystery. Science has revealed the logic behind its beauty. Well, this is where our colorful journey into why the sky is blue comes to an end. As you can see, it all starts with sunlight dancing through the atmosphere. Rayleigh's scattering spreads blue light across the sky and our eyes take in its beauty. Red at sunset, orange on Mars, black in space, it all depends on the magic of the atmosphere. So, what do you think is the most interesting thing about the sky being blue? Or if you wanted to live on another planet, what color sky would you prefer? Be sure to share in the comments, I'm very curious. If you liked this video, don't forget to like, subscribe to my channel and hit the bell icon. In the next video we will dive into another why question. Take care and enjoy the sky.